laws of physics themselves. You know, a good friend of mine is Dr. Grady McMurtry. He's a former evolutionary scientist turned creation scientist. And Dr. McMurtry and I, we've been good friends for probably 25 years now. And Grady has told me, when he was an evolutionary scientist, I asked him, what is it? What is it that caused you to realize evolution had to be wrong? Now, keep in mind, Dr. McMurtry, you'd have to know this guy, he's a brainiac. I mean, just to give you an idea, how many of you have heard of Mensa? You've heard of Mensa Society, right? The high IQ society. This is for the people with the highest of IQs. Okay, well, within Mensa, there's a special elite group of Mensans. Okay, it's called Intertel. Intertel is the highest of the IQs of the Mensa members. He's not only a member of Mensa, he's a member of Intertel, okay? He's a born-again believer in Christ. He travels the world spreading the gospel of Jesus Christ, and he uses scientific evidence to prove this is true.
I debated Grady McMurtry. His relevant education is in forestry, not evolutionary biology. He claims to have been an evolutionist, and he claims to have taught evolution, but with me, he immediately revealed that he never even knew what evolution even is, not even the basics. I had to teach it to him, but he still wouldn't learn because he's dishonest and stupid, in the sense that he would not accept correction even when he was clearly wrong, demonstrating the point that the illusion of false knowledge really is more dangerous than ignorance. He couldn't describe any of the evolutionary mechanisms. He even denied natural selection. Even Ken Ham and Kent Hovind admit that natural selection is a demonstrable fact of population genetics and environmental dynamics, but not Grady McMurtry, because he doesn't know the first thing about evolution. He didn't know what microevolution was, much less macro. He couldn't define either one. So yeah, typical creationist moron. I'll include a link to that debate below so that everyone can see that Grady McMurtry had absolutely no idea what he was talking about at any point in our debate. He literally got everything wrong, just like you've been absolutely wrong on every single point you've tried to make so far in this discussion. No wonder you and your friends.
And he told me, Bob, I'll tell you what messed it up for me. What was the catalyst for me realizing that must all be false and God's word must be true, was the issue of gravity. He said, because there is no scientific method by which gravity can evolve.
That he decided young earth creationism, that he decided the Bible and magic fruit and talking snakes is because there's no scientific method by which gravity could evolve.
There's no scientific method through which you can go from non-gravity to gravity existing. And I'm like, okay, that's pretty scientifically highbrow for me, but that's what it was for him.
Gosh, what a good question. Of course, that's not the way I ever thought about it, but I as I have sometimes done on this project, I've reached out to experts, and in this case, Phil Halpher, SkyDivePhil on YouTube, has done a couple of documentaries where he's assembled some of the top minds in the world to talk about the eternity of the cosmos, for example. And I'm going to put a link to one or two of those below. Phil Halpher is a fellow of the Royal Astronomical Society, a YouTuber who's interviewed many of the world's leading cosmologists, including Stephen Hawking, Roger Penrose, and Alan Guth, as well as Sean Carroll and so on. And he was appointed journalist in residence at the Penn State Institute for Gravitation and the Cosmos. And he has a book coming out next year with Chicago University Press, co-authored with cosmologists Nayesh Ashfordi, entitled The Battle of the Big Bang. Phil,
hey.
When this book comes out, be sure to let me promote it with you.
Oh, that would be lovely. Thank you. Yeah.
So what do you have to say about this so far?
Well, I mean, there's a number of things to say. Firstly, why does gravity, the law of gravity, need to evolve? Why can't it just always have existed? I don't see any reason for that. So I just don't see what the problem is supposed to be. Secondly, it's certainly true that we don't understand where the laws of physics come from. Why are they the way they are? We don't know. There are sort of ideas that physicists have played with. Some think they're just necessary. They just have to be the way they are. Others, like Lee Smolin, for example, will suggest that maybe they evolve. We don't know, but I don't think you can infer anything about God or the origin of the universe from any of these considerations. We don't know the nature of the laws and why they take the values, why they take on the form that they do. But there's certainly no reason to think they have to go from not existing to existing. Even models of the universe where the universe sort of comes into being, as it were, like Alex Vilenkin has a model like that. The laws are sort of presumed to be eternal.
That was my understanding. I mean, in order for something to exist, it has to have properties, right? Well, so asking, well, why does it have to be these properties? I don't understand why there has to be a concept of a beginning implied where there's no beginning implied. That's part of the argument. Where did everything that always existed come from? Well, if it always existed, then it didn't come from anywhere. Why is it daily people accuse me of believing that everything came from nothing? I don't know anybody that ever believed that anything came from nothing, but we're accused of that every day, aren't we?
Well, it's certainly true that a lot of apologists keep saying, well, if you're an atheist, you have to believe the universe came from nothing. You don't have to believe that, and it's not implied by atheism. It may be that Lawrence Krauss wrote this book called Universe from Nothing. Lawrence Krauss is an atheist, and therefore people assume that, well, atheism then implies the universe came from nothing. But atheism doesn't imply that at all. And you could be an atheist and believe the universe came from nothing, or you could believe that it's always existed, or you could believe it came from a black hole. In our book that's coming out next year, it's all about different competing models for what might have triggered the Big Bang. And there's all kinds of ideas. I think we have something like 24 of them.
That sounds exciting. I mean, I've been told of other models besides the Big Bang, and I'm intrigued. And
well, we have to be a little careful when we say alternatives to the Big Bang. The phrase Big Bang can have different meanings. Mm-hmm. So this is something we cover in the book, but it should be at least two ways to think about it. One is you could talk about the Big Bang expansion. So this, you could define this as a theory that says the universe came from a very hot, dense state 14 billion years ago, roughly. That is not up for dispute. That is overwhelming evidence for that, and I don't think anyone seriously disputes that. But there's another way to define Big Bang, which is that it's a singularity, an evolution from an infinitely hot and dense state, and that marks the beginning of time. And that certainly is up for dispute. And I would guess that most physicists don't accept that. But it's certainly, we have to be very careful not to confuse the two. So when people say alternatives to the Big Bang, keep that in mind when you're thinking about what do we mean by Big Bang.
Well, what I understood is that not every model necessarily has or always had, not all of the models that have been proposed always had a singularity. And when they do, there's different aspects to it or different ways to understand it. But the only way that I've ever understood it is that there was never just nothing.
Well, there is a model proposed by Alex Vilenkin that I would say is close to the idea of a universe coming from nothing. So in his model, you can think of it this way. So you can have fluctuations of the vacuum. And it was proposed in the early 1970s by someone called Edward Tryon that the universe came from a fluctuation of the vacuum. Now, people say, but that's not nothing because the vacuum isn't nothing. And that's right. The vacuum isn't nothing. However, what Vilenkin suggested was that maybe if we treat space and time quantum mechanically, they would fluctuate into existence from a state where there was no space or time. So the initial size of the universe, if you like, would be zero. So that you could consider, I would say, a universe from nothing. Now, the only thing that would still exist are the laws themselves. So it would be from nothing material, which is what theists often claim God does. He creates ex nihilo. So I think John Lennox is an Oxford theologian who said, I believe the universe came from nothing, but but not nothing. I can't remember exactly what he said, but nothing. It came from nothing material, but it didn't come from nothing. I think that was the phrase he had. But that's what's being proposed here by Vilenkin. But we have to remember that Vilenkin's proposal is a speculative proposal. It's one of many, many different ideas. It's certainly not implied by atheism. You don't have to believe in this model if you're an atheist.
No. The other thing is that there's being an investigation, there's different answers that are possible. There's different ways to understand this. And the only way that, as I said, that I understood it was that there was always, material energy in some form. The singularity, it was there already at the beginning, before the beginning of time, in my understanding of it. So there was never, and Sean Carroll told me that universal wave function was, and thus, properties of the universe had to already exist forever. Right.
I think it would be wrong to say they have to. There are proposals where that's the case, but we have to be honest and say we don't know. No one knows whether the universe had a beginning or whether it didn't. Both options are ones we should consider and be open-minded about. In models where there is a beginning, there's a beginning of cosmic inflation, but not necessarily of the universe itself. Well, even that's up for dispute. I mean, inflation is a period of exponential expansion that's hypothesized to have existed in the early universe. My guess is most cosmologists accept inflation happened, but not everyone. There are some prominent cosmologists that don't think inflation even happened. There are alternatives to inflation. Most of them are eternal into the past. Inflation, did it have a beginning? Well, there's a theorem that says inflation had a beginning called the Borda-Guth-Vilenkin theorem, but that has been challenged by other physicists saying it's not even valid. So, and there's no experiment that we can do to confirm whether it is valid or not.
So the way I've explained this to other people is that I try to tell people that it's irrelevant to me. I mean, there's, as you said, there's no way we can know. And it wouldn't matter what the answer is, if the universe had a beginning or if it didn't, or what that explanation might be. None of that changes the fact that we are evolving apes, and that all of the scriptures, every religion, are all man-made mythology with no truth in them.
Yeah, I mean, there's no question that the two issues are just unrelated. So you can believe the universe is eternal into the past, or you can believe it had a beginning. And whatever position you take on that shouldn't affect your position on whether evolution happened. I mean, that's just.
But we are told
overwhelming evidence for human evolution for sure, and other forms of evolution. So to me, that's not up for debate. Whether the universe had a beginning is up for debate. I think it's a profoundly interesting question, but it doesn't change about anything about evolution. It doesn't change whether you can be an atheist or not. So you can be an atheist and be, like myself, open-minded about whether the universe had a beginning, or you can believe it did, or you can believe it didn't. Nothing follows about atheism about whether it did or didn't.
Well, the point that I was curious about is that we're told that this so-called brainiac doesn't know how a thing that might have already been eternal evolved, and so he assumes that it has to have begun and that it evolved for whatever reason. And because he doesn't know that means that snakes can talk, and that magically enchanted fruit can cause you to know things, and that fables and folklore that we know are wrong about everything have to be absolute truth, because we don't know how gravity evolved. That just doesn't seem like something that I think a conclusion that a brainiac would come to.
Well, to be charitable, I mean, I think he might have some other argument for believing in the Bible, and this might be an independent argument for believing in God. I don't think it works. There's no reason to think gravity has evolved. I mean, when we look at the laws of nature, they don't change ever. There's no evidence that the laws have ever changed. So, why should we demand we have to have some explanation of how they can evolve from not existing to existing? There's just no reason to even demand that. I mean, you can posit that the laws change and speculate on that. Maybe they do, but there's sort of to demand. that atheism must give an explanation as to how these laws go from non-existing to existing. It's just a stupid question, in my opinion.
The laws of physics themselves make the no God scenario impossible. And let me just give you a brief example of this. There's something called the conservation of energy law and the first law of thermodynamics. Sounds pretty highbrow, I know, but let me put this into very simple terms, okay? You can't, whatever amount of matter and energy there is, they can be converted into each other, but however much total stuff there is, you can never increase or decrease that total amount. It has to be conserved. It has to stay the same. That's a law of physics. So I can't make this disappear. I can burn it, but it's still going to exist. It just exists in different forms. Okay? So the total amount of stuff has to always exist. That means you can't go from nothing to something.
And here he is saying that we have to believe that everything came from nothing again.
Well, there's so many things wrong with this statement. It's hard to know where to start. So let's pick something. First off, it's technically just wrong. The reason that's wrong is because conservation of energy is not a fundamental concept in physics. This is something you learn. The conservation of energy is something you might learn in high school. But at a higher level of education, you're going to learn that actually conservation of energy is a derived concept, okay? So, it was derived by a very, very famous mathematician called Emmy Noether. She was an amazing figure, in the early 20th century. She was barred from a lot of the universities, and a lot of people complained, having a woman teaching men in those days was scandalous. But she was very brilliant, and she showed that conservation of energy is actually derived from symmetry principles that exist in the universe. So in particular, something called time translation symmetry. And what that means in plain language, for our purposes, is that certain properties of the universe don't change. So in particular, like the curvature of the universe doesn't change. So given that, you have a conservation law. So it's certainly true that in the room that person was in, yes, if you burn an object, it will just transform its state from one to another. But at very, very large scales, the time translation symmetry is broken by the expanding universe. So where you feel the expanding universe, you break time translation symmetry. And what that means is conservation energy doesn't apply. Now, what scales are we talking about? So certainly in this room, conservation of energy applies. On this planet, it applies. In our solar system, it applies. Going out to distances until you feel the expansion of the universe, it will apply. So all the way out to at least Andromeda Galaxy, which is, I don't know, what's it, 2 million light years away, it still applies. But when you go to really far distances, it doesn't apply. So it's just not true that conservation of energy is relevant for the universe, because think of it this way: when the universe expands, the cosmic microwave background is losing energy. Where does it go? It doesn't go anywhere. It's just lost. So it's not getting converted into something else. Similarly, empty space has energy. So when the universe expands, there's an increase in energy. In fact, some people have wondered whether maybe there is some conservation of energy at these large scales, and maybe the decline in the energy of the cosmic microwave background is giving energy to empty space. But people have worked on that and found that it doesn't work. Bottom line is conservation of energy doesn't apply to the universe. It only applies to local areas of the universe where you don't feel the expansion. So yes, it applies in the solar system and the galaxy and very large distances, millions of light years, but not billions of light years. It doesn't apply there. So that's the first thing to say. Second thing to say is, even if conservation of energy does apply, it doesn't follow that the universe couldn't come from nothing, because what could be the case is that the negative energy of gravity could perfectly balance the positive energy of matter, so that the net energy of the universe would be zero. So it wouldn't violate any conservation laws for it to come into being from nothing. So that's the second point. Third point is atheism doesn't predict that the universe came from nothing. So, even if you want to believe all the other things that it couldn't come from nothing, so what? Atheism doesn't predict that the universe came from nothing. As we said before, it's simply one idea that's been proposed. There's many other ideas. Doesn't really matter if that one's true or false for the belief in God.
Yet the universe, if the atheists are true, if there's no God, somehow we went from nothing to everything. The entire universe came into existence somehow on its own. And that's a violation of scientific law. That's just not possible. The no God scenario is impossible according to the laws of physics themselves. There has to be a God, because if there's no God, nothing has to stay nothing. That is required.
Well, again, atheism doesn't predict that the universe came from nothing. So it could just be a tunnel into the past. Nothing wrong with that.
As I find funny about that is that the creationists are the ones who believe in creation ex nihilo.
Right.
I've seen statements from the Institute of Creation Research that they say that they necessarily believe that everything came from nothing, literally. God spake everything out of nothing, and that's what they're required to believe.
Well,
But they're always accusing me of believing that, and then pretending as if they don't believe that.
Yeah, so it's certainly true that modern creationists believe that God created ex nihilo without any existing materials. So if you're going from your experience of the world that you know, everything that's created is created from pre-existing materials. So either you say, well, my experience of the world and what I've learned from that is irrelevant. There's just an exception at the beginning of the universe. Or, you want to say, well, maybe God made from pre-existing materials. And there have been religious people that believed that God did make from pre-existing materials, that he didn't make creation ex nihilo. And there's nothing in the Bible that says God created ex nihilo. It's certainly true that it is a common belief by modern creationists that God did that. But God, there's certainly traditions where God created the universe from a sort of existing chaotic realm.
We're dealing with young Earth creationists.
Modern day young Earth creationists tend to believe that God created.
We're not dealing with adept theologians. We're not dealing with people of deep philosophical considerations, not even scriptural analysis, because there's so many different ways to when it says that God created the heavens and the earth. There's one way to imply that maybe that the earth and the heavens are created as separate things, and somehow the earth is the first thing at the beginning and the center of the universe. But I mean, there's advanced theologians don't hold that position.
What it says in the Bible is not God created heavens and the earth. Okay, if you know the Hebrew, you know that the actual words are God created the land and the sky, not heavens and earth. People translated them into that because to some people they're the same things. But I think to a modern ear, heavens would refer to like the universe, but it doesn't say that. It's the sky. How do we know this? Because the Hebrew words are Hashemayim and Haaretz. So Haaretz means the land, because in the Bible it talks about the land of Israel, the land of Goshen, so on, land of Egypt, and it uses the same word, Haaretz. And if you know any sort of Jewish folk songs, they often talk about Eretz Israel, the land of Israel. So it means the land, and then Hashemayim is where the birds fly. Right, so it's the sky that's created. It doesn't talk about the universe at all.
Well, there's also two different ways of looking at when God says, "Let the earth bring forth the living creature after their kind." Mm-hmm. There is an interpretation of that is perfectly in line with abiogenesis and evolution, and then there's this other interpretation where the guy's just saying magic words to create every species, which that's not where we're going.
Okay.
So,
yeah.
Now, sometimes the atheist will say, well, maybe the universe always existed. Well, that's a nonsensical argument, too. That's not possible because of something called the second law of thermodynamics. And the second law of thermodynamics, it's a heat transfer law that heat will trend toward a colder body toward a state of equilibrium. Okay.
The second law actually, more specifically, is about how many microstates will give you a certain macro state. So it's a bit of a sort of simplification to say it's a heat transfer law.
What that means in very simple terms, fifth grade language, if I put a cup of hot coffee here and I put a cup of ice water here, there's a difference in the temperature, right? The coffee's hotter than room temperature. The water's colder than room temperature. What is going to happen eventually to the temperature of these two liquids? We all know, right? They're eventually going to become the same temperature as their surroundings. Okay, that's the second law of thermodynamics at work. This is a scientific law, it's a scientific principle. It's been proven to be true. So if you walk into a room and I've got those two liquids there, and they're both room temperature, equal temperature with the room, I don't know how long they've been there. But if the coffee is still hotter than the ice water, what I know scientifically is it's impossible they've been there forever, right? Now, let's go back to the atheist who says, well, then maybe the universe existed forever. That's not possible because you still have hot things that are hot in the universe, like stars. You still have cold things that are cold. You have a disparity of temperature in the universe. That means it's scientifically impossible the universe has been there forever. That's why they say, okay, then we go back to the original, and then we went from nothing to something. The first law doesn't allow that. Well, okay, then it always existed. The second law doesn't allow that. Well, maybe there's multiverses, an infinite number of universes. Number one, there's no evidence for that.
I think it's funny that he's going to criticize somebody for believing something when there's no evidence for it.
And number two, you still have the same problem because of all the multiverses, where'd the first one come from? How did you go from nothing to something in the first one? Okay, and then secondly, if there's multiverses, how do you still have disparity of heat? Because eventually they can't be around forever. They would have had to have lost energy too. So I'm just saying that it's actually the atheist who is rejecting scientific law.
Okay, so let's review. Basically, so his definition of entropy is sort of oversimplified. The more precise definition is, as I said, it's like how many microstates will give you a certain macrostate. So you can think of it this way. Imagine I have a pack of cards, okay? Now, the order of the cards, when you open the cards, is like ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, so that's the order of the cards, yeah? Now, if you shuffle the cards, so that's one way the cards can be, okay? Now, if you shuffle the cards, what's the chances you're going to get the original order back? There's many more ways for it to be random than there is for it to be that order, okay? So that's what we would mean by going from sort of low entropy to high entropy, i.e. the disordered state is more probable than the ordered state. Think of it another way, actually. This is an example given by Leonard Susskind. So imagine you've got a bunch of coins on a table and they're all heads up, yeah? Now you start flicking them. There's more ways for it to be random, i.e., lots of heads and lots of tails, than for them all to be heads. But it's not impossible for them all to be heads. You could throw them all and they all come heads, okay? Very, very unlikely, but not impossible. So when we talk about entropy and the second law, what the second law actually says is that it's overwhelmingly more likely for entropy to increase into the future. So, but it's not impossible for it to go down, but it's just very, very, very unlikely. In the same way, if you shuffle the cards, very unlikely they're going to get back to the same or the original starting place, but it's not impossible. Similarly, if you have all these coins on the table and you throw them, chances are they're not all going to be heads. All right, that's a very ordered state. They're all heads. Much more likely you're going to get a random state, heads, tails, in a sort of random order. So that's what the second law actually says. Now, what he says is a sort of approximation. It's not like wrong, but it's an approximation is something a bit more profound, which is that the entropy has to go up over time. You can recast the argument in a more precise way, and more sophisticated theologians have done this. So let's be a bit charitable and put it in the more precise way. That is, if the entropy is going up, eventually you get to a maximum entropy state. This is like equivalent to him saying that the temperature of the whatever it was, the drink and the room have to equilibrate. So in a sense, that's basically saying they must reach a maximum entropy point in a finite amount of time. So therefore, given that we're not in a maximum entropy state, Therefore, the past must be finite. That's basically a more precise way to formulate the argument. A more sophisticated theologians like William Lane Craig or whatever would put the argument in that way. So let's be charitable to this guy and say, right, that's the argument. So what's the problem with the argument? Well, there's lots of problems with the argument. Where to start again? Let me think. Okay, so first off, it assumes that the maximal entropy state can be reached. However, if the maximal entropy state is infinite, then it can't be reached. You'll just keep going on and on and on. You never reach a maximum entropy state. Or you could start with an infinite, if the universe was infinite in the past, the entropy could always be infinite, in which case you can just add to it forever, no problem. Another problem is that, there are certain mathematical functions where if you go back into the past, you just get smaller and smaller and smaller and smaller, but it doesn't ever reach zero. So you could have a function like that perfectly consistent with being infinite into the past. Another issue, and I think this is where the biggest puzzle is, and maybe where we can focus the discussion, is that we do know that the Big Bang started in a very low entropy state. And so there is a mystery as to why. If high entropy is more probable than low entropy, why did it start in this very low entropy state? Now, you might argue, if you're a theologian or a theist, oh, well, God wanted there to be a very low entropy state so that life could exist. But that doesn't really work, because the entropy could have been much, much higher and life would still exist. So this is not like a fine tuning like some of the other claimed fine tunings where, if it was a tiny bit different, life couldn't exist. No. The entropy could have been much, much higher and life could have existed. So why was it so low in the past? First, so it's mysterious. You might imagine, okay, there was a previous universe and maybe it just randomly went to zero and then it increased again. Not statistically impossible, but very, very unlikely. So you might say, well, we should probably rule that out. But notice one thing. A low entropy point is unlikely anywhere in the timeline of the universe. So if you put it at the beginning of a model with a beginning, you have a mystery. Well, why was it so low? If you put it in the middle of a universe with no beginning, right? Imagine there's a contracting universe from infinity and expanding universe out to infinity, and you put the low entropy point in the middle, that's no worse than putting it at the beginning of a universe with a beginning.
Now, are you talking about something like a Big Bang, Big Crunch kind of oscillation?
Well, it would be well, it wouldn't necessarily be oscillating. You could have that, but it doesn't have to be that. So you could have just what's called an hourglass universe, where there's just two phases, a contracting phase and an expanding phase. So there's not a cyclic universe where it's expanding, contracting, expanding, contracting. It could just be what we might call a one-shot bounce or an hourglass universe. I mean, you could imagine a cyclic one as well, but you don't have to, right? So the question is, the low entropy is a mystery for any model of the universe, whether it has a beginning or not. So it doesn't tell you that the universe had a beginning. There are ideas out there. For example, Roger Penrose has one. Other people working in loop quantum gravity have this idea, where maybe the entropy basically of the universe prior to the Big Bang, if there was one, is sort of trapped there. And the slate gets wiped clean as you go from a pre-Big Bang universe to a post-Big Bang universe. So that would explain the low entropy condition, and it would be perfectly consistent with an eternal universe. So, so I would say that the argument is wrong for a number of reasons. Then it assumes that the maximal entropy state can be reached, but maybe it can't. It assumes the entropy was a finite value in the past. It might not have been. It doesn't really explain where the low entropy came from. That's a problem for models with a beginning, as it is a problem without a beginning. So it doesn't discriminate. There are proposals that would allow for an eternal universe with a low entropy state. And funnily enough, I'll end the point with this, is that you've got Alan Guth and Roger Penrose, very, very famous cosmologists. Alan Guth invented inflation. Roger Penrose won the Nobel Prize for his work on black hole singularities and Penrose-Hawking theorems and so on. And they both agree, actually, that the way to solve the entropy puzzle is an eternal universe into the past. Now, they're very different conceptions of an eternal past. They certainly don't agree with each other on what the nature of that eternal past is. Penrose has a cyclic cosmology. Guth doesn't. But they're both eternal into the past, and they both agree that the eternal universe is the answer to this mystery as to why the entropy is low. So, but ultimately, the argument is just wrong on many different levels. Lower entropy pockets can sort of pinch off from a mother universe where the entropy is still increasing. So that would be allowed by the second law, no problem. It would explain why we have a low entropy beginning, and the entropy can just increase forever. So that would be consistent with an eternal universe. The statement there's no evidence for a multiverse, I don't know if that's really correct. It depends what you mean by evidence, of course. And I certainly wouldn't want to claim that the evidence for the multiverse is overwhelming. That's certainly not true. But is there no evidence for it? I would dispute that. I mean, it's complicated, but so I'll just try and sort of lay the case out very simply as I can. There's this theory called inflation. It's a theory of the early universe that says it expands exponentially. And this theory seems to suggest that we live in a multiverse. Most cosmologists would say there's evidence for inflation. In fact, on NASA's website, they say we found evidence for inflation. Now, there are disputes about this evidence, whether inflation is really correct. So that's why I say the evidence is certainly not overwhelming, because you can challenge whether there really is evidence for inflation. There's a debate about that. But it certainly isn't a wacky view that there is evidence for inflation. I would say it's pretty mainstream. And then we interviewed him for one of our videos, George Eustathio, and he says, well, I mean, he was the person that gave the cosmology results for the European Space Agency's Planck satellite, €1 billion satellite to map the cosmic microwave background. It's the most accurate map of the cosmic microwave background that we've ever seen, and will be for the foreseeable future. Well, in fact, future missions won't try and make more accurate maps. They'll try and do polarization. So it's probably as accurate as you're going to get. So, and he said, yeah, the types of inflation that are favored are very conducive for making a multiverse. They are eternal, what's called eternal inflation. Although Alan Guth has suggested that almost every model of inflation leads to a multiverse. There are different models of inflation, which is where some of the debate lies. So I would say there's at least a case to be made that there is evidence for a multiverse. It can be disputed. I don't want to sort of overstate it. So it's a controversy that exists in science at the moment. People argue about it and debate about it. It's certainly not any kind of fantasy invented by atheists. That's definitely not the case. So now you could then ask, well, where did the first universe come from? If there is a multiverse, again, it's not clear that there had to be a first one. People quote this theorem by Borda, Guth, and Vilenkin, but there's lots of debates about that too. So, there's certainly no consensus about any of this stuff. And, I think he's wrong to say there's no evidence for multiverse. I think it would be fair to say there's no conclusive evidence for multiverse, or no compelling evidence. It's suggestive and it's debatable. And if there is a multiverse, it's not clear that it needs to have a beginning. And if it does need a beginning, well, it could come from some other process. Maybe there's something that gave birth to the multiverse. Maybe there was a collapsing universe and then it expanded. And when it expanded, that's when the multiverse starts.
I don't see why there should be a begin when we're talking about the subsets, the products of this being eternal themselves. Why would there be a finite beginning to a multiverse?
Well, I think the reason that someone might appeal to is this theorem by Borda, Guth, and Vilenkin. But as I say, that theorem is disputed. So people might be surprised at that, but they can go on my channel, and there's a video that we made called well, if you click on the cosmology playlist on my channel, Phil Halpher, we talked to some of the scientists that dispute whether this theorem really sort of proves the universe had a beginning. And if in fact, Guth and Vilenkin don't say anymore that it proves that there was an ultimate beginning. The claim is that there was a beginning to inflation. So that might be a beginning to the process that gave birth to the multiverse. But as I say, others think even that's wrong. That actually the multiverse can exist eternally into the past, and even if it didn't, there could be some other process that gave birth to it. So there's really nothing here that demands a first universe. There's nothing that demands from the second law that the universe must have a beginning. All these claims are just false, in my opinion.
Thank you very much, Phil. Always a pleasure.
You're welcome. Yeah.